Section 4.5, Implicit Differentiation. The learning objectives for this section will be to use special functional notation and to carry out implicit differentiation. First, we want to look at function review and new notation. So far, the equation of a curve has been specified in the form of y equals x squared minus 5x or f of x equals x squared minus 5x. This is called explicit form. Y is given as a function of x. So before, when we looked at equations, they were always in explicit form because we always had y written as a function of x or f of x, which is the same thing. However, all graphs can also be specified by equations of the form f of xy equals 0, such as f of xy equals x squared plus 4xy minus 3y squared plus 7. This form is called implicit form. You may or may not be able to solve for y. So, we'll look at how to differentiate equations in either form. Explicit and implicit differentiation. Consider the equation y equals x squared minus 5x. To compute the equation of a tangent line, we can use the derivative y prime equal to 2x minus 5. This is called explicit differentiation. So before, we just took the equation y equals, and we took y prime of that equation. Just moving the exponent for x, 2 out in front, x, reduce the 2 by 1, minus 5, bring the 1 out in front, 1 times x to the 1 minus 1, which is 0. So we had y prime was equal to 2x minus 5. Now, this was the slope of the tangent line. Okay, we can also rewrite this equation to be an implicit form. Okay, so if I take my y and subtract it from each side of the equation, I'll get x squared minus 5x minus y equals 0. This is implicit form. And we can calculate the derivative of y from that also. Okay, so let's look at example 1. It says to consider the equation x squared minus y minus 5x equals 0. Okay, we will now differentiate both sides of the equation with respect to x. Okay, which differentiating with respect of x is the same thing as taking d dx of both sides. Okay, and keep in mind that y is supposed to be a function of x. So, from the equation, I take my x squared minus y minus 5x, and I take d dx of that. Okay, and then on the right side, I take d dx of the constant 0. Okay, if I differentiate with respect to x, x squared will become 2x, minus y will become minus 1, but since we're differentiating y with respect to x, we want to include dy dx, minus 5x differentiated will be minus 5, equal, the derivative of a constant is 0. Okay, so we have 2x minus dy dx minus 5 equals 0. Notice here, we're isolating dy dx on the left side, and we're subtracting 2x. Oh, so here, let me put it here. We have negative dy dx is equal to, if I subtract 2x on both sides, I get a negative 2x. And then add 5 on both sides, I get plus 5. Okay? From there, notice that we've divided by a negative 1. So if I divide dy dx by a negative 1, I get a positive dy dx. If I divide a negative 2x by a negative 1, I get a positive 2x. And if I divide a positive 5 by a negative 1, I get negative 5. Okay? So we get the exact same thing as the previous slide. Y prime is equal to 2x minus 5. Okay? But in this method, we differentiated using implicit differentiation. Okay? Before we consider example 2, let's look at another example. Okay, so this example says to use implicit differentiation to find dy dx using the following steps. Step 1, differentiate both sides of the equation with respect to x, finding d dx of both sides. Step 2, collect all terms with dy dx on one side. And 3, solve for dy dx. Okay, so for step 1, we're going to differentiate both sides with respect to x, taking d dx for both sides. Okay, so I have d dx of x cubed plus y cubed equal to d dx of 8. Okay, if I'm differentiating with respect to x, I have 3x squared. In this case, since I'm differentiating with respect to x and it's x, it's dx dx. Okay? Now, I won't have to write dx dx because that's just equal to 1. So anytime you differentiate with respect to x and your term is just an x term, you won't need to include dx dx. Okay? So I'm going to erase this part now. Okay? Now I want to find d dx of y cubed. Okay? So I'm going to take the derivative of y cubed, which is 3y squared. But since I'm differentiating y with respect to x, I want to include dy dx. Okay, and we must always include dy dx if we're differentiating with respect to x for a y term. Okay, equal to d dx, or the derivative of a constant, is just 0. Okay, so that's step 1. Step 2 says to collect all terms with dy dx on one side. So notice here I only have one term. In order to get dy dx on one side, I'm just going to subtract 3x squared on both sides of my equation. Okay, so I get 3y squared dy dx equal to negative 3x squared. Okay. Step 3 says to solve for dy dx. So notice here, since I have 3y squared dy dx equal to negative 3x squared, I only need to divide both sides by 3y squared to isolate dy dx. Okay, and if I simplify this, I can cancel out the 3's. So dy dx is equal to a negative x squared over y squared. Okay, which this also can be considered y prime. Okay, let's look at the next example. Okay, here we want to do the same thing, use implicit differentiation to find dy dx. Okay, so step 1, I'm going to find d dx, or differentiate both sides of the equation with respect to x. Okay, so d dx of the left and d dx of the right. Okay, so here I'm going to differentiate 4x squared with respect to x. I get 8x dx dx. Okay, differentiate a negative 9y squared with respect to x. I get minus 18y. Since I'm differentiating y with respect to x, I must include dy dx. Okay, equals d dx of 17, or the derivative of any constant, is 0. Okay, step 2 says to collect all terms with dy dx on one side. So notice here, negative 18y dy dx is the only term I want on the left. So here I have negative 18y dy dx. If I subtract the 8x on both sides, I get that equal to negative 8x. Okay. Step 3 says to isolate dy dx. So in order to isolate dy dx, I'm going to divide by negative 18y on both sides of my equation. Okay, so I have dy dx is equal to negative 8x divided by negative 18y. If I simplify, dy dx is equal to 4x over 9y. Okay, dividing both the negative 8 and the negative 18 by a negative 2. Okay, or just canceling the negatives. Okay, so there's my dy dx. Now let's consider the function x squared minus 3xy plus 4y equals 0 and differentiate implicitly. Okay, before we begin, let's look at this middle term. Okay, well, here I'll just look at that term. I'll distribute the negative later. Okay, so notice here I have a product 3x times y. Okay, anytime we differentiate a function that is a product, remember we want to follow the rules where if I'm taking d dx, the product rule of of a first term times the second term, I get the derivative of the first times the second plus the derivative of the second times the first. Okay, this is what we're going to use to differentiate the product 3xy. Okay, or 3x times y. Okay, so step 1, I'm going to differentiate both sides of the equation with respect to x. Okay, so I have d dx of x squared minus 3xy plus 4y equal to d dx of 0. Okay, so d dx of x squared will be 2x minus d dx of the product 3x times y will be the derivative of the first. The derivative of 3x is 3 times the second plus the derivative of the second, which is y1 dy dx. Okay, because we're taking the derivative with respect to x times the first 3x. Okay, plus we want to differentiate 4y. So we're differentiating with respect to x. So we'll have 4 dy dx equals the derivative of 0, or any constant is just 0. Okay. Now I want to distribute my negative sign here. Okay. So I have 2x minus 3y minus, bring the 3x in front, 3x dy dx plus 4 dy dx equals 0. Okay, step 2, I want to collect dy dx terms on one side. So I'm going to have negative 3x dy dx plus 4 dy dx equal to, moving 2 over, I'll get negative 2x, and negative 3y over, I get plus 3y. Okay, or subtracting 2x on both sides, adding 3y to both sides. Okay, so here we have dy dx. If we factor out a common factor of dy dx, we have a negative 3x plus 4 equal to negative 2x plus 3y. Okay, so if I solve for step 3 dy dx, okay, I'll divide both sides of the equation by negative 3x plus 4. So I'll get negative 2x plus 3y over negative 3x plus 4. Okay? And in this case, since the top part and the bottom part starts with a negative